Hi class, in this video I'm going to explain how to make a parametrically driven uh, comb where that we have one dimension, our driving dimension, the length of the comb, and we can update that dimension and we'd like our CAD model to be able to automatically update. So I'm going to go through how we could build this CAD model. But first, what we really need to understand, we know that the thickness, Tn, of the combs should not change because we're given that's a fixed variable. And so what will change? Actually, any dimension on this that is just a fixed number, those are fixed dimensions. So for example, this fillet radius right here, that's fixed. These holes diameter of 0.25, those are fixed. These dimensions of the profile of the side right view of the comb is fixed. What is variable and is going to depend on L is the spacing. So what you can sort of see in these the picture up in the upper right here is that as the length of the comb grows, the number of comb teeth stays the same and their thickness stays the same, therefore the spacing must change. So what we need to do is actually derive an equation for this spacing. In order to do this, it might be simpler to look at a comb with fewer teeth. So here I have a comb with 2 teeth. And if we say that the length of the comb is some variable L, we can define this length as a vector addition by going one thickness two, or sorry, another space. So we go the vector distance t, the vector distance the space, then we have another thickness of a comb, then we have another space, then we have another thickness of the comb. And of course, this doesn't look like the comb that we are going to CAD, but this could be useful for any general comb where we say n is the number of comb teeth. So we can make this depend on the number of comb teeth that we have. And so the vector equation here would be that the length of the comb would be equal to n times the number of teeth plus n minus 1, because there's always one less space than there is comb teeth. So n minus 1 times s. And of course, we don't know s, we know L, and we know T, and we should know n. So the question mark is, well, what is s? So we just rearrange and solve, and actually now we have a function for s based on our driving dimension L. So this is what we need before we could actually build the CAD. So now I'm going to go through and explain how we could build this CAD model. So taking a look at the dimension drawings here of the orthogonal projections, we have a front face and a right face. And there's kind of two choices. We want to first identify if there's any symmetry. And in fact, there is a plane of symmetry right down the middle. And since it's in 1, 2, 3, 4, 5, 6, 7, 8, 9, so it's an odd number of teeth. That means actually right down the middle of this uh, is this tooth right here is our plane of symmetry. And we kind of have to decide is what sketch or sketches are we going to need to make? And what you see from this right profile is that we can't really get the dimensions of this right profile by just sketching the top. So there's actually several different ways to do this, and I'll explain two ways that might be most common, but you may find other ways that would work for you. So let's take a look at the CAD. Okay, so for this, what I've decided to start with was the right sketch. And the reason being is because I can get most of the complicated geometry from the right sketch. And actually the second reason being is there's kind of two really logical sketches that you could probably use. That was the right sketch, you could extrude most of the body, and the front face, you could extrude the comb teeth, but you actually don't even need that. So I'll show you both ways. But before we do anything, uh, if I were to have in this right sketch any parametrically linked dimensions to the driven dimension, then I would need to actually make that driven dimension right now. But actually what you can see from the right plane on the homework was that there was no dimension, so all of these will be fixed. So these are all fixed dimensions. So I made this first sketch on the right plane. Okay, and there's no fixed there's no driven dimensions. But now, before I go any further, I need to put in a parameter. So actually, I've pinned it to my toolbar, but under Modify, all the way at the bottom, what we want to do is add parameters. And so the first parameter would be L. And this parameter we can update to be our length. And we could actually make one, let's call L1, and that was actually given as 2.96. We could make L2, and that was given as 3.96, or really L1 plus 1, so maybe it's L1 plus 1 inch. And then we had L3, which was L1 plus 2 inches. Okay, but I actually just want a more generic parameter called L that I'm going to use, and I guess I could set it to be L1 at this point. And before I go any further too, what you're going to want to make sure is your document settings are set to inches because they may be millimeters. Make sure that you change your active units to be inches. So just everybody make sure you're doing that. So I'm going to modify my parameters. And here is where I'd probably add some of the other parameters that were in that equation. So N was, and I better put a comment in here to explain that this is the number of teeth. And in this case, we counted 9. Okay, I need to change the unit to be no unit because this is just N a number. There's no units associated with it. I'm going to add another parameter, what I'll call T, and this will be the thickness of the comb. And that's fixed, so that doesn't depend on L. That's 0.12 inches. But here's where we'll get the spacing S. And if you type in S, it won't let you. So they have maybe somewhere internal to Fusion, they've already used this variable. So I might call it space. And that's pretty descriptive. But now I can put in our equation. And we said that this was L minus N times T. And then we could divide all of that by, make sure you're using your PEMDAS, so your parentheses, but this would be where we put N minus 1. And now that's a variable that should be dependent on L and N and T, of course, really, but T here is going to be fixed, so T will not be driven by L. Okay, so now let's go back. Now that we have the parameters that we can actually use these global variables to make our model. So you may want to make an extrude, and you could use symmetry, so you could extrude out both ways. Actually, if I use that, and normally I do, it becomes slightly more difficult to do the pattern, but still not impossible. But I'm just going to actually extrude out a distance. Now that I have that parameter L, I'm just going to use it. Okay, so there is that L. And just before I go any further, to make sure that this is working, what I better do is I better change L and see if my whole model updates. So if I were to type in L2, what I want to see is that this body should grow by 1 inch, and in fact it does. And if you measure one edge down here, this is 3.96. And so I'm going to go back, and let's put this as L1. So L will be L1 for now. Okay, and now this should go back to 2.96. And now that we already have this sketch, I'm actually going to use it again. So I'm going to do an extrude of that, but instead of starting from my profile sketch plane, I'm going to turn off the origin because it's kind of confusing now. So instead of starting from here, we need to start from an offset plane. And since we have a parameter, we can just put in t. And then the distance would be the spacing. And actually, by default, it's going to set that to be a cut operation. Okay, and now that we have one, we actually have a feature that we could pattern. So under the solid pattern, we could create a rectangular pattern of a feature, and the feature would be that cut feature that we just made. The direction would be along the x-axis. So we can select the x-axis as our direction. And we're given two vector directions, x, and perpendicular to that would be y. But we don't want any patterns in the y, so that one we'd move down to 1. And the number of that we're going to pattern is actually, this will be n, but it's -1. And the reason it's n minus 1 is because we're actually patterning the gap, not the number of teeth. And then the distance really depends on the distance that you select. So the extent is a little bit harder to calculate, but you could still do it. But I'm going to do spacing. That's a little bit easier. You can see from this picture, you have to go the spacing of an entire space plus the thickness of a comb. So the distance would be space plus the thickness. And that's it. So now I've patterned it and I've got all of those teeth. Now, what we really want to make sure is that our parameters update and the space and everything updates and it doesn't break. So now if I go into our parameter L, which is our driving parameter, and I actually might, if I double click on this, let's add a comment that this is the driving parameter, just so I don't confuse it. But if I now type in L3, it will automatically update. So the spacing automatically counts. The thickness is fixed, so we're not changing that thickness. And something I'm going to do now, which I normally don't do until the very, very end of an entire model, is what we see, and I'll show you here, is what we see is that all of the edges are supposed to be given a fillet of 0.03. And so there is a lot of edges to select. This could take an eternity to select all these edges, but Fusion, unfortunately, or fortunately, gives you a tool. Under selection filters, we could change it instead of select all, or select through, instead of select all, what we like to select is body edges. And so now if I select over this comb, I've actually highlighted every single edge, except that there are two edges that I don't want to fillet because they are not actually of the same radius. And that is, if I hold shift, I can unselect stuff. So I don't want to fillet that edge. And I also don't want to fillet that edge. But now I've got all of my edges selected other than the one I don't want to fillet. And so I can press F or under modify, do fillet. And then we give it a fillet of 0.3. Now, actually, sorry, I'll show you. Let's go ahead and do this. And this is why I normally like leaving fillets to the very end. Okay. We actually wanted to fillet these edges first. So if I go fillet, I'd like to click that edge and that edge. And those are supposed to be 0.25. So 0.25. Oh, and Fusion figured it out. I was actually kind of surprised. I thought it would. This prior fillet may give it an issue. So we now have that fillet. Okay. We're not completely done. We need to get the holes. And so to do that, I'll leave that up to you, but you probably should use another sketch and define where those holes exist, but still use the hole tool to make the holes. So now I'm going to talk about the other way that we could have used to get this. Instead of having only one sketch, it may make sense to have two sketches. So the alternate way would be if we wanted a sketch on, I would probably select the XY face. What we could do is we could take a projection of our model. Okay, so pressing P to make a projection. I'm actually going to hide the bodies. But now what you'll see is this projection would actually update if I update my parameters because it's parametrically linked to this parameter. So if I move this L back to L1 and press OK, that actual projection also updates. And maybe you didn't see the other extrude method that I did, but you did see this method. So what I'm going to do is this second method. So you could make using the line tool, and we could dimension this was fixed at 1.25. And then the space between here and here, of course, would be the thickness, T. So we need to have that parametrically linked. We need to have, sorry, T defined before we'd actually use that. But now you see in the sketch, there's this f of x. That means that this 0.12 is driven by a parameter. And then this will be our spacing. So we type in space. Okay. And now as we go with sketches, we like to make sure everything is fixed. So good, we are fixed. And this might be, let's call this the teeth extrude. It's always a good idea to name our sketches sketch. Okay. And instead of like our other operation where we pattern the extrude feature, actually in this sketch, we're going to go ahead and make a pattern. So go ahead and click rectangular pattern. And the things to pattern will be basically those three lines, and the direction will be basically the same thing, this x direction. We still do not want any in the one direction, and actually we could do this patterning just like we did before. So this is still going to be n minus 1, and the distance will still be space plus t. But say you forgot the t, and let's just say we did space, and you clicked OK. And then you're looking at it and you're like, uh-oh, that doesn't look correct. It's a little bit more obvious how to update a pattern, edit a pattern, say the one that we did as a feature, but you can also edit patterns for sketches. So there's a little icon here. And oh, I got to go back to my selection filter. Make sure that we can select all. So it's not letting me select it. So if you do edit your selection filter, make sure you go back to select all. So now I can select that and right click it, and I can edit my rectangular pattern. And actually it's supposed to be space plus T. So that's nice that you can edit the sketch linear pattern. And there I have my profile. So I finish my sketch, show the bodies, and then I'm going to hit my extrude. And the profiles are going to be, actually it's easier to select them from the bottom. So all of these profiles. And then the distance would be all. And there we have our parametrically linked comb. And let's just triple check that this updates. So we could change this to L3, and it still is parametrically linked. So hopefully this video shows you how you can use parameters to derive your CAD design.